Today we are doing 7.9 multiplying mixed numbers. So far we've practiced looking at them and estimating, is it greater, is the answer, the product, greater than, less than, or equal to. We looked at how it would look in a model form, and now we're going to learn the skills we need to multiply mixed numbers confidently. So today our goal is to be able to multiply the mixed numbers by changing mixed numbers to improper fractions. That's a very important step. Go ahead and make sure you write that down, as well as the date in your journal. Let's go ahead and do some practice review in your journal. And let's write that these are examples of how to change mixed numbers to improper fractions. So these are going to be examples of how we do this. And there's a few steps. And the easiest way to remember this is that, okay, so you have your whole number, and then you have your numerator, and then you have your denominator. If I can spell denominator. And then, of course, we have our line to represent that the numerator goes on top and the denominator goes on the bottom. And this is our whole number. Now, this is a mixed number. This is why we have this. This is our definition of a mixed number. A number that is bigger than 1, but it's still a fraction. So we have our whole number and a numerator and a denominator. So how we would change that from a mixed number to an improper is with this problem. It's kind of the opposite of what we've done before when we've changed it from an improper to a mixed number. So you take the denominator, or I'm just going to shorten it for denominator, and you multiply that by the whole number. And you do that first, so I'm going to put that in parentheses. And then, after you have the denominator times the whole number, you add the numerator. And guess what? That's going to equal our new numerator. And I'll put a line. And our denominator stays the same. So this is going to be the same. So notice I've got my denominator, denominator stays the same. The only thing that's really changing is the whole number is added to our numerator. And our numerator changes. So we have our numerator, these here, and then we get our new numerator, which I'll put in pink because it's new. That's the thing that's changing. So we're going to follow this model today. So make sure that this is clearly written in your notes. We're going to practice changing these three mixed numbers into improper fractions. So normally you'll look at this and say that is the simplified fraction. This is exactly what I would like it to be. But when we are multiplying mixed numbers, it is a lot easier to do this step to solve your problem. Okay, so we're going to follow this. We have our whole number. I'm going to use the highlighter so you can see these are our whole numbers. This is our denominator. And we have our numerator. And we want this equal to a fraction that is improper, where the numerator is bigger than the denominator. And remember, the new numerator is going to go on top, the one that we don't know yet. That's what we're trying to figure out. But the denominator is going to be the same. So it's the same as in yellow. So I'm going to go ahead and first thing I'm going to do is I'm going to change that first part so I don't forget that my denominators stay the same. Okay. And then I'm going to solve it this way. I have my denominator. So let's start over here. We've got 4. And we're timesing it by our whole number. And then, remember we do that first. And then we'll add that to our numerator. And that will get our pink answer. Okay, so 4 times 2, that is 8. Let me just write that above there. 8 plus 3 is 11. So 11 is my new numerator. And that's how we do it. Let's practice that again. So, whole number times the denominator plus the numerator equals our new numerator, and the denominator stays the same. That's why I've already moved it over. So 4 times, so I have 4 pieces equal 4, times 4 plus my numerator equals my new numerator. 4 times 4, well that's 16. 16 plus 1, that's 17. There's my answer. Okay, let's show it again. We've got our denominator times our whole number, and we do that first, and then we add our numerator. So 2 times 5, well, that's 10. 10 plus 1, that's 11. Uh-oh, did I miss? There we go. And that goes right here. Denominator stays the same. As you can tell, the only thing that we're really changing in our final fraction is the numerator, and that is in pink. Everything else is just a step to the problem. Let me show you how I do this without showing you the numerical expression. Let's scroll this down a little bit. I'll bring these up. Okay, so same steps. Remember, I want it equal to something, and I want this equal to something. And I'm going to use the highlighter again so you can make that connection that my denominator is staying the same. I have a whole number, got the numerator, but the number that's mostly changing here is my new numerator. That's what I'm trying to figure out. So 3 stays the same. 8 over here will stay the same. Now, instead of writing it out like this, which I think is helpful if you struggle with this, there is, oops, I want to make sure that stays yellow. There is just a simple way that I do this. And because I look at the problem and I think, okay, 3, and I kind of write a little times right there. 3 times 1, and I have to think to myself, okay, 3 times 1 is 3. And then I kind of write a little add sign here. They look very similar, so I kind of have to make sure that I'm clear that 3 times 1 plus 2 equals, and so I'm kind of doing like a half circle around to find my new numerator. So I kind of just do that like half circle around to find my numerator while the denominator just stays the same. So 3 times 1 is 3 plus 2 is 5. And so I kind of just do that half circle to find my numerator, and it allows me to do the math in my head. But sometimes if it's a little bit more difficult, if they're bigger numbers, I will write it out like this to show my work. So here, 8, I write my times sign, go with half circle. 8 times 2, well, that's 16. 16 plus 3, that's 19. I'm going to double check my work. 8 times 2 is 16, plus 3 is 19. There we go. And when you're doing it this way, you can always check your work with the calculator on the computer and just a double check to avoid those simple mistakes. So I've got 8, I'm going to times it by 2 plus my 3. Yep, that's 19 over 8. Let's check our work over here. 3 times 1 plus 2. Yep, that's 5. So I was able to show my work. And here is my answer. Hopefully today when we use that method, you can feel confident to do that step quickly and successfully. Don't forget that all of this needs to be in your journal. Okay, we're going to move on to your big math book, but remember, your big math book is still part of your notes. So in the end, I would actually like you to glue the important parts of page 325 and 326 into your journal. Okay, so let's go ahead and start with page 325. Now, there are two ways that you can solve mixed number problems. One way is to use a model, and the other way is to rename the fraction mixed number as just an improper fraction. So I'll show you the first way first, so you can connect that as a visual model. So let's read the problem. 1/3, so we have 1/3 of 1 1/4 acre park has been set aside as a dog park. Find the number of acres that are used as a dog park. So we have 1/3 of 1 1/4. So that's 1/3 times 1 1/4. So remember what we learned from estimating. When we're timesing a mixed number by a fraction less than 1, my answer is going to be a smaller number than 1 1/4. So we are going to shade the model here to represent the whole park. So we have 1 1/4. So I'm going to shade, let's do it in yellow, 1 whole and 1/4. So the whole dog park is 1 1/4 of an acre. Well, we're going to double shade the model to represent the park where the dog park's going to be, and that's 1/3 of it. So if you remember, we kind of break it into 3, and we double shade it. And let's use the pink because we're trying to find our new numerator, remember? And it turns into red when it's double colored. So I'm going to color in, going all the way over. 1/3, not 2/3, because only 1/3. Now anything that is double shaded is going to be my answer. Hold on, let's think that the dog park is 1/3 of the park. We drew the horizontal lines to show thirds. How many parts does the rectangles now show? Okay, let's think this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Now you might make this mistake and count up all of them, but remember it's just out of one whole. What fraction of each rectangle is shaded twice? 1, 2, 3, 4, 5 pieces are in red. Or if you look at this way, it's 4/12. So this is 4/12, and then we have 1/12. So together, 4/12 plus 1/12. That's going to equal 5/12. I kind of skip that part. I just kind of counted up all the ones that were double shaded. But it is important to notice that it's 4 plus the 1 over here. So in the end, we have 5/12 of an acre that has been set aside. Now I'm going to show you the other way that we solve these problems, and it's just how we rename the mixed number as a fraction. So you see here that we've got a couple different steps. We have to draw, we have to count, we have to double color. Down here, we're just going to do the half moon thing here. We're going to kind of whip around to figure out, change this from a mixed number to an improper fraction. Okay, so we're going to write the mixed number as a fraction greater than 1. So if we're timesing 1/3 by 1 1/4, 1 1/4 is the one we need to change. Notice here the denominator stays, oh, we don't want pink because pink's our new numerator. Our denominator is staying the same. And we want that new numerator. So I'm going to kind of do the whip around method for, actually I'll write it up here first. 4 times 1 plus 1. Remember, I kind of want to do that first. So 4 times 1 is 5. I'm sorry, I almost led you astray. 4 times 1 is 4, plus 1 is 5. So 5 will be our new numerator. Now we're not done though, because we have to still multiply it. And that's why we've got 1/3 times 5/4. And we are just going to move this down here. Multiply straight across. 1 times 5 is 5. 3 times 4 is 12. And there's our answer, 5/12. You might ask yourself, how do we know if it's simplified? Remember, to find greatest common factors, I find my 5, which is 1 and 5. 5 is a prime number, so really I'd only have to see if 5 can go into 12. It can't, so 1 is my greatest common factor here. So it's already simplified. Go ahead and do a couple more practice problems. So we're going to now do a problem that is 12 times 2 1/6. So it's a whole number times a mixed number. We're going to definitely get a bigger number here. So we're going to write the product also in simplest form. So that's always that last extra step. It should always become habit. I know when we have fractions, there's practically a million steps. We can do it though. Okay, so we're going to, step 1 is we're going to determine, we already determined that 12 times 1/6 is going to be greater than 12. So we kind of did our estimating. We know we're looking for a greater than number. It's going to be bigger than 12. And then we are going to write the whole number as a mixed number and the mixed number as fractions. So both of these need to be as fractions. Well, 12 is kind of easy, right? We just put it over 1. So we change 12 over 1, and that's a fraction. Now 12 and 2 1/6. Remember, we go 6 times 2 plus 1. So 6 times 2, when we go this direction, kind of going around this way. So 6 times 2 is 12, plus 1 is 13, and 13 is our new numerator, while the denominator stays the same. Then we solve, multiply straight across. 12 times 13 is 156. That is definitely a lot. There's sometimes that I will probably want to get a calculator just to double check that. 12 times 13, it is 156. So I did that step correctly. Okay. And then I put that over 1 times 6 is 6. Boy, look at that problem. I definitely know that needs to be simplified because it's an improper fraction now. We've got a bigger number on top, smaller number on bottom. We really need to simplify this. So let's go 156 divided by 6. Can 6 go into 1? Nope. Remember, daddy, mommy, sister, compare, brother. So we divide. Can 6 go into 12? 15? Yep, it can go into it 2 times because 2 times 6 is 12. Subtract 3, and then we don't forget compare, smaller. Yep, I'm good. And then bring down. Can 6 go into 36? Yes, it can. It can go into it 6 times. 6 times 6 is 36. Awesome. I think we don't have anything left over. So we have our whole number right here. So, or this could be 26 over 1 if we were to simplify it, or pretty much that's just 26. So 26 is our answer. So we multiplied the fractions, we wrote the product in simplest form, and so 12 times 2 and 1, 6, that's just 26. And now let's compare it back to step 1. 26 is definitely greater than 12. Let's go ahead and use, actually another method that you could use is the distributive property to solve 16 times 4 and 1/8. And don't forget writing the problem in simplest form. We're actually just going to rewrite the expression using the distributive property. If this confuses you, don't pay attention too much. You still need to recognize what a distributive property looks like, but I want you to feel confident about this. And there's many different ways to solve math. And one way is not always the correct way. There's a lot of different ways to get your answer. And I'm going to show you that today. So remember distributive property, 16 times 4 and 1/8. That's just like breaking it apart. 16 times 4 plus 1 and 1/8. So it's just kind of, we broke this up a little bit. And then distributive property is saying that, hey, we could just times 6 times 4 and then add that to 6 times 1/8. And we would get the same answer. So like 16 times 4, 4 times 6 is what? 24. 4 times 1 is 4, plus 2 is 64. Notice they even have your answer right here, but let's show it anyway. 16 over 1. 16 times 1 is going to be 16. 1 times 8 is 8. Oh, that is definitely an improper fraction. 8 can go into 16 2 whole times, so that's how we got our 2. 64 plus 2 is 66. So that is using the distributive property, just pretty much saying that if we could times this whole number by each one of these separately and add them up to get our answer. So 16 times 4 and 1/8 is just 66. Let's do some more practice problems. All right, I'm going to probably go quite a little bit faster, so hopefully we can keep up. So we're going to write the product, find the product, and write them in simplest form. Now here, I have 2 mixed numbers. I want to change them both to improper fractions. So remember, 3, so I'm going to do the half loop around. 3 times 1 is 3, plus 2 is 5. And I'm going to do the same here. 5 times 3 is 15, plus 4 is 19. And remember, I can grab that calculator and double check. 3 times 1 3 plus 2. Yep, that's 5. And then we've got 5 times 3 plus 4, 19. Yep. And then we can solve 19 times 5. 19 times 5, that's actually 95. But let's do it right down here anyway. Oops. We're just going to times it by 5. 5 times 9, that's 45. Oops. Put my 5 down here and my 4 up here. 5 times 1 is 5, plus 4 is 9. So that's how we get the 95. 3 times 5, that's 15. And then I have to simplify it because that's an improper fraction. 15 can go into 95 6 whole times, but let me show you. Remember, the only time I do this is when I have an improper fraction. Some of you were doing it when you had just a basic fraction, that would get you a wrong answer. Only do it when my numerator is bigger than my denominator. So I have my 95, 15. 15 can't go into 9, but it can go into 95. Think about it, 15, 30, 45, 60, 75, 90. So that would be 6. 6 times 15 is 90. With 5 left over. So 5 is our new numerator with 15 at the bottom. I could also look at this and say, hey, I can simplify that. But if you did get this answer, I'd give it to you. But 5 can go into 15. So that would actually simplify down to 1/3. Because I would divide both by 5 to get smallest answer. 5 divided by 5 is 1. 15 divided by 5 is 3. So there's my smallest number. Let's go ahead and show it again one more time with a model so you can see 1 and 1/3. Got 1 and 1/3. And then I am actually just going to take this, cut it in half, and color in half of it. And then I need to add up the ones that are double shaded. 1, 2, 3, 4. That's my new numerator. And count up how many are in 1. 1, 2, 3, 4, 5, 6. I see a greatest common factor of 2, so I divide both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. There's my answer. Okay, let's do, if you feel like you understand this, let's do one more problem and then you can stop the video and keep going. However, I will show a couple more examples for you. So we're going to use the distributive property here. So remember, this can also be written as 16 times, break it up to plus 1/2. We broke it up there, and then we're going to kind of change it around and go 16. We could just times that by 2, and then also times 16. So we're just kind of distributing it out. 16 times 1/2. And then we'll add those two together. So 16 times 2, that's actually 32. And 16 times 1/2, I could put it over 1. 16 times 1 is 16. Over 2, because 1 times 2 is 2. That's going to equal 8. Plus 8. My answer is 40. I'm going to write the 40 right here. And then circle it, because there's a lot of room there. Okay. If you feel like you understand this and you just want to get going, remember anytime you can keep going, but down here I want you to choose 4 problems from 9 through 16. You get to choose, and I want you to choose 1 distributive property to do. So 4 from up here, 1 from down here. Okay. For those of you who want another, some extra examples, let's go ahead and do it. So remember, first step is I'm going to change these to improper fractions. I'm definitely going to want some extra room here to show my work. So get a different piece of paper, use your journal to show that you're working on this problem. 1 times, so I'm doing the 1 times 8 is 8, plus 1 is 9, and the denominator stays the same. And then I'm timesing that by 3 times 2 is 6, plus 1 is 7. And remember, I can double check with a calculator. Denominator stays the same. 9 times 7. Think about it. That's 63. And 8 times 3, 8, 16, 24. There we go. Now, again, I know this is a lot of steps, but you kind of have to think to yourself, that is a really big number. Let's first make it a mixed number and then simplify it. So I'm going to take 63 and divide it by 24. Because it's an improper fraction, I only do this for the improper fractions. I know that it can go into it 2 times. 2 times 24 is 48. And then let's subtract it. I have to regroup here. That's a 5, 13. Then that means this is 5, and that's 1. So remember, that's my new numerator, 15 over denominator stays the same, which is 24. And then, oh, as much as we really love to stop there, because remember 63 over 24 is equal to 2 and 15 over 24. It's just making it from an improper to a mixed number. We actually have another step. We have to find the greatest common factor of 15 and 24. Yeah, I know, it feels like these steps are never ending. 15, remember I always pick the smallest one first. 1 and 15. 3 can go into 15 5 times. And that's it. Okay. So, can 1 go into 24? Yes. Can 3 go into 24? Yes. 3 can go into 24. 5 can't go into 24 and 15 can't go into 24. But I could divide both my numerator by 3 and my denominator by 3. And get my answers. So 15 divided by 3, that was 5. 24 divided by 3, that's 8. And the 2 stays the same. Wow, you can tell how many problems that is. We had to do 1 step here. Let's count this out. Let's figure out how many steps that we just did. You can feel very proud about yourself. There's 1 step, 2 steps, 3 steps because we had to change from an improper to a proper, 4 steps because we had to find the greatest common factor. And then fifth steps, just because we're tired. Wow, that's so much. If you did this one with me, I'm going to count that as one of your 5 problems. So you really only need to do 4 more. Go slow, use extra paper. Make sure you show me each one of these. And so that way that if you got a step wrong, we know what happened. So show me all your answers. Show me this one, show me this one, and show me your final. Okay, I want you to get going. If you still feel like you don't understand this, please come to a small group table. Good luck.